Okay, so there's a little bit I want to add to the parent functions, and that is the end behavior. So, in Algebra 2, and I don't know, maybe in Pre-Calc 2, when you talked about end behavior, you wrote it formally, like as x approaches positive infinity, f of x approaches blank. Okay, all I want right now is just to describe the tails, like where are they going? And we're looking at y. Okay, so from left to right, this tail is going down, and this tail is going up. So that's all I have. That's all I'm going to write. So end behavior. And I want to put it in the correct order. So it went down, up. That's all I need. Okay, for absolute value, my end behavior, so always left to right. So the left side is, and the right side is up. Okay, so up, up. Okay, quadratic. What's my end behavior? Up, up. So square root's a little different because you only have one end, but we'll just describe that one end, and it's up. Okay. A cubic. What's my end behavior here? Down, up, and cube roots is the same. Down, up. Okay, so that's all we needed to add. There's a few questions that talk about the tail end behavior. All right, so let's get back to the transformation. So we did vertical and horizontal shifts. We talked about that at the end yesterday. And so now I want to talk about reflections. So if you reflect over x, there is a negative outside the function. So in the very front, there's a negative, and that means you reflect over x. So if you have a quadratic, instead of opening up, it would open down. Okay, a reflection over the y-axis has a negative inside the function. So the x is negative. The x itself is negative. There's a negative out front. And that means you reflect over the y. Okay, so I want to look at these two examples and describe the transformation. Okay. So first of all, I see this plus 2 on the inside. So I got to do order of operations, which we're going to talk about in just a minute. So I want to take care of what's on the inside first, inside parentheses. So when I say plus 2 on the inside, that means I shift horizontally. And so which way would I shift? Left. When it's on the inside, we're the opposite. Okay, so that was here. Then I have this negative out front. So this negative out front, it's out front of my whole function, not just with x. It's out front of the whole thing. So it's a reflection over the x-axis. Okay? Let's look at our next example. So this example, let me first rearrange it so the x is written first. Okay, so if I do my order of operations, I see this negative here first, and it's negative x, the negative's on the inside, so I reflect over the y-axis because the negative is on the inside. All right, but then I see I have this plus 3. So we know we move horizontally, and we want to say that we move left 3 because we know when it's on the inside, it's the opposite. However, when you do your translations, your horizontal translations, if the x is negative, then you got to think about that it's actually the opposite of this 3, 2, and I'll show you why in just a minute. So it's actually like this. Okay? It actually has the minus 3 because when you do your horizontal shifts, you have to be just looking at x, not the negative x. Okay, so I'm actually moving right 3. Alright, so there were 2 transformations here and 2 transformations here. Okay, so I know that part's a little confusing, but let's graph it, and I will show you why that's the case. Okay, so we'll talk about the 0 in just a minute. Let's just graph it. So it was g of x equals 3 minus x. But let me rearrange that. And my transformations were reflect over y. So I'm just copying this down from the previous problem and shift right 3 because that's like a minus 3 here, and then it's the opposite of that, which is right 3. This doesn't happen very often. Most of the time you don't have a negative inside with the x, but if you do, remember that it's going to reflect over y, and then it also affects your horizontal shift. Okay, function. So what type of function is this? Square root. So let's graph f of x equals the square root of x. So you graphed this one on your warm-up, so you know you're at 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so what I do to graph this is I do those order operations and I do them in order. So the order matters. I'm going to use each point and I'm going to reflect it over the y-axis and then shift it right 3. So you have to kind of keep track of the points that you're doing. So I like to start with the initial point or the vertex or whatever that special point is. So I'm on the y-axis, which means if I reflect, I stay on the y-axis. And then I go right 3. Okay. Here, I reflect over the y, so I'm 1 unit away on the right. So if I reflect, that would put me 1 unit away on the left. And then from here, I go right 3. Okay, now let me do this point. I reflect, so I gotta go, I'm 4 units away on the right, I gotta go 4 units away on the left. And then it says I go right 3. Okay. So each point, now I need to reflect, and then right 3. So this is my new graph of g of x. So I want to talk a little bit about why we're shifting right 3 instead of left, like why we have to do the opposite there. And I can tell you that if we find the 0, we know this is the point, not negative 3, 0. So finding the 0 means you plug 0 in for y or for g of x. And let's solve. So we square both sides. This is not something that we have to do every time right now. I'm just showing you why we have the point 3, 0 and not negative 3, 0. Obviously, some of you are probably good with because I said so, but this is also for those of you that aren't okay with that. Negative 3 equals negative x. So 3 equals x. So that means I have the point 3, 0. So that also convinces me, okay, so it's 3, 0, not negative 3, 0. I did have to shift right. Or if we talk about the domain. So we found domain over stuff like this, plenty. The domain of this is the square root, so that means what's underneath has to be greater than or equal to 0. So if I'm finding the domain, I want to solve this inequality. Subtract 3. Divide by negative 1, which means you have to flip your sign. So x is less than or equal to 3, so my domain is negative infinity to positive 3. My maximum is at 3, and the graph goes to the left, which is what I have. So if you have a negative next to x, then your horizontal translation is not the opposite because you have opposite here. You already have the opposite here. So this tells you reflect over y, and you've already done the opposite, so you shift right 3. All other times, the inside is the opposite. Yes?
For the domain, my picture is negative x plus 3 squared.
Whenever we find domain of square roots, we always start with setting what's underneath greater than or equal to 0.
Right, so why didn't you do negative x plus 3?
It would have been the same thing. I could have. I just started from the original. Yeah. Yeah. Okay? So reflections over y are the only ones that are kind of have to think a little bit more about, but all the other ones, whenever it's inside your horizontal translation, you're doing the opposite. Okay? Okay, let's talk about stretches and compressions, or stretch and shrink. So stretches and shrinks come from numbers out front. So numbers out front that are being multiplied. So we're not talking about a negative out front, because remember, the negative out front means there's a reflection. So if there's like a -2 out front, the negative does not do anything for the stretch and shrink. The negative is a reflection, and the 2 is what you look at for the stretch and the shrink. So if that number, and we say absolute value again because we're not looking at the negative, if that number is greater than 1, then it is a stretch. Okay, most of the time, so like if you're looking at a quadratic, your the graph would be narrower. If A is between 0 and 1, again, so we're not saying negative, that's why between 0 and 1, then there's a shrink. So you shrink it, so if, like a quadratic, your quadratic would get wider. Right? So this would be like 1/2, or 2/3, or 0.8. Right? So a number between 0 and 1 for your shrink. So looking at this example, we're just going to say, okay, let's just say f of x is this single point here, 2, 4. Okay, so here's f of x. All right, so if h of x is 1/2 of f of x. Okay, so these are vertical stretches and shrinks. Because, remember, f of x is just a way to write y. So really what I'm doing is just 1/2 of the y coordinate. So 1/2 of 4, which equals 2. So h of x is 2, 2. My x coordinate does not change. My y coordinate changes. Okay, so 2, 2 would be h of x. All right, same thing now, g of x. Again, I'm just going to leave this negative out front, and I'm going to do 2 times y. Because f of x is another way to write y. So that's -8. And I'm just keeping it in parentheses just to emphasize that the negative does not make this a stretch or a shrink. It's the 8. So it's going to be 2 -8. Okay, so back to h of x. This was f of x. This is now h of x. So this was a shrink. It got smaller because 1/2 is 1. All right, now this is a stretch. But if I do order of operations, I would have to reflect first And then I do my vertical stretch of 4. So this is negative 2 multiplied by 4 is negative 8. So I need negative 8 here. There's 2, 3, 4, 5, 8. That's the point to negative 8. So I can tell here was f of x. This was a stretch. F of x grew twice as long and reflected. So your stretch and shrink only affect the y coordinate. Yes. Yeah. Okay? Questions about that? Okay. So these are our order of operations. So that was all the transformations. This is the order that we do them in. There are things on your test that will say, describe the order of operations. So you will have to write them in order, and we're going to practice a few of those. Okay, so this is reflections over y-axis is in red here because remember that will affect your horizontal shift. So that's the one that just changes things a little bit. So that will be when there is a negative inside next to x. So that's what we'll do first. Then we have a horizontal shift. So that's when you have something added or subtracted inside. A reflection over the x-axis is the negative out front. Stretches or shrinks has the number out front. And then vertical shifts, that's the last thing we do, and that's always what's added or subtracted at the very end. So it looks like this. Just if f of x is any type of function, then this is the transformed, so applying the transformations. F can be any function, quadratic, cubic, linear, absolute value, etc. There will be. Okay. So I'm not going to graph this, but I am going to describe the transformation, so talking about the order of operations. Okay, so then I'll locate the vertex, center, inflection point, or initial point. So it's just one of those things depending on the type of function. So inflection, it depends on the book that you look at, see how you want to spell it. I'm not going to count off for the way you spell that. Like if you, I sometimes use the X, and it doesn't matter. All right. So first of all, what type of function is this? Okay. And absolute value has a vertex. So the parent function has that vertex at 0, 0. So that's what I'm using here. I'm not going to use center, inflection point, or initial point. This one has a vertex. Okay, so describe the order of operations. So think about order of operations when you're doing this. So you know you would work inside first. Is there a negative in front of this x? No, so I don't have the reflection over y. So the first thing that's happening to x is this minus 4. That tells me I'm going to do what? Right 4. Shift right 4. Okay, good. Next step would be this what's out front. First thing we do is for negative. So remember, the negative is not necessarily part of that 0.3. So the negative out front means I reflect over x. Good. Okay. Then there is this 0.3. So a number out front means I have a stretch or a shrink. Is 0.3 bigger or smaller than 1? Smaller. So is it a stretch or a shrink? Shrink. So we have a vertical shrink by 0.3. That means I'd be multiplying my y coordinates by 0.3. And then the last thing is this plus 5. So what does that tell me I do? Shift up 5. So my new vertex, so the vertex is affected by just the translation, so just the vertical and horizontal shifts. The reflections don't change it, and the stretch and shrink does not change it. So your vertex is just affected by your shifts. So if you went right 4 and up 5, that means your new vertex is 4 or 5. Yeah. Okay. Questions about that? All right, we're going to do another one, and then we're also going to graph it. What type of function is this? Good. So its inflection point starts at 0, 0 for the parent function. Okay, order of operations. So first thing that's happening to x is the plus 1 on the inside. So that means I shift left 1. Okay. So you can either, put an arrow there, or I sometimes think it's helpful to cross it off, so I know I've taken care of that part. Nothing out front. I don't have a negative. I don't have a number, so no reflection over x, no vertical stretch or shrink. So the next thing I just have is this 5, so I have to move up 5. Okay. So I'm going to graph that, and I'm going to graph the parent function first, at least plot the points of the parent function. Okay, I'm just going to plot those points, and then I'm going to use the transformations in order with each point. It doesn't matter if you like to start, like if you want to start up here and work your way down, that's fine. I usually start with the special point, whether that's a vertex or in this case an inflection point. So if I go left 1 and up 5, that means my new inflection point is at -1, 5. Okay, so maybe I'll put a little check mark next to that point so I know that I moved that one. So if I do this one, left 1 and up 5, be up here, left 1, up 5, and I move that one, left 1, up 5, and left 1, up 5. Okay, and there is my graph. So it should still look like a cubic when you're done. That's how you know if you did all the correct transformations to your points. It should look like you took your cubic function and shifted it left 1 and up 5. Okay? Let's do another one. So I'm going to call that g of x just so I can have a more specific name for it. What is the parent function? Okay, cube roots. So this also has an inflection point. So if I just plot those points, I would have 8, 2, and -8, -2, 1, 1, -1, -1. Okay, so here's the parent function. All right, so for g of x, if I do my order of operations, what do I do first? Left 2. Good. Then what? There's a negative out front, so it is right 2. Thank you. Thank you. Right 2. Sorry. And then I reflect over x-axis. Okay? And then finally, up 3. So I got to go in that order with the points. So if I start here at my inflection point, 0, 0, and I reflect over x, I'm on the x, so I don't change. But I have to go, I go right 2, and then I go up 3. So that's my new inflection point. 2, 3. So remember I said the only thing that affects those special points are your translations, right? Where you shift left, right, up, or down. Okay, so I did this one. So now maybe I'll start here. I got to go right 2, and then reflect over x. So I'm 2 units away from the x above, so I got to go 2 units below. And then I go up 3. So I get a point right here. Okay? So that was this one. So I go right 2 first. So I'm here. Then I reflect. So I'm here. And then I go up 3. And that's where my final point is. So that's why I think it's helpful to like maybe put a little check mark by the points you've done, because it gets kind of confusing. We have a lot of points going on, but you just go in order with each one. Okay, so if I do this one, I shift right 2, so I'm here. I reflect over X, so I'm here. And then I go up 3. So my final point is there. Okay. And then this last point, I go right 2, reflect over X, and then up 3. So when you're done, it should still look like a cube root. Right, and it should look like you did these order of operations, that you went right 2, up 3, and you reflected over the X. Because here's your original. Here's the parent function. So you can tell that it's been reflected over the X. Now my line of reflection isn't exactly the x-axis anymore because I have those translations. But at one point it was reflected over the X. Okay? Okay with that? Alright, so if we think about going backwards, now we have the graph and we want to write the equation. Alright, so this form here looks confusing because of this f and x, but it's this form because that means for any type of function. So our first step is to just identify the function. So what is the parent function? What's the parent function? Square root. So I have to know the shapes of my parent function so I can identify them on a graph. Okay, so I need it in this form. H and K is fine. And I would fill in my variables A, H, and K. All right, well, let's do H and K because that's usually the easiest. So that's here. That point is -5, -3. So remember, H comes from how you moved left or right, and we always do the opposite. So I moved left 5, so that'll be +5. And then I went down 3, so what would I put at the end? -3. Now the tricky part of these is figuring out A. Okay, well first of all, did I reflect this at all? No, because if you reflected over X, it would look like this. If you reflected over Y, it would look like this. Okay? So I didn't reflect at all, so I know that there's not a negative out front. But I need to see if I had a stretch or a shrink. Well, what you can do is just see if your points line up, because in this case they do. So if you have square root, you go over 1, square root is 1. You go over 4, square root is 2. You go over 9, square root is 3. So the A is just 1. I did not have a stretch or a shrink. So I can say that this is my equation. to figure that out. So this is a quadratic. I can tell by the graph it's a parabola. So right. This is the vertex is -3 or +3, -3. Okay. So +3 means x -3 here, and then going down 3 means -3. Okay. Are we okay with that? So now I'm going a little fast. All right. Well, I know the pattern is not right, and my parabola is off a little bit, just on the graph, because 1, 1, -1, there need to be a point right here, and then 2, 4, right here. So I can tell it's narrower. So to find A, I have to plug in a point that's given to me for x and y. So f of x is our y, x is x. So -1 equals A, 2 -3 squared minus 3. And I solve for A. Okay, so 2 -3 is -1. So, right? -1 squared is 1, and 1 times A is A. Okay, add 3, so 2. So A is 2. So then I can write that back into my equation. 2 x -3 squared minus. That will help you even if A is negative, even if you reopen down, it will give you the negative value for that.